name is Guenther Fleischer. I work for Siemens AG in Nuremberg, responsible for microgrids in the region of Asia, Africa, and also Belgium. Quickly go through the topics today. I've got changing landscapes. I think our previous panel had a big discussion on this as well. The microcontrol technology, the CCAM application, the basis of what we're using, and also some references that we have, which are always interesting. So let's look at the landscape, and this is the traditional landscape that we have is the generation on one side, the transmission, and then the consumption on the other side. Very simple, very straightforward. This has been going on for years. So there's no rocket science here, it's quite standard. But what's happened at the moment, these things become very complex. So at the moment, we have a lot of different types of energy sources feeding into the grid at a distribution level, making it much more complex because everyone has the possibility to invest in these technologies, making it a complex situation. So this is something that we have today. And going further than that, people are seeing that they can invest in their own microgrid, they can invest in their own generation, creating a microgrid, the requirements for microgrids to exist in industries and communities, etc., hospitals, etc. This makes it also very challenging for all of us. But this also sees for the customers where they have increased reliability because they can control their own energy. They also have better energy cost savings because using renewables is a topic here as well. And also improved grid resilience because they're controlling the grid and they might be in an area where the grid is very, very weak. Or, for example, lowering emissions as well. They might be using diesel and it might not be a big topic on the islands, but it might be a topic in the cities to lower the emissions. So if we look at the energy landscape, the old energy landscape we have today, where we have coal leading to a lot of climate change issues. We have the costs of these issues as well, because who would have guessed the price of these energy costs would raise in 1 year so high and be so unpredictable. So previously, one could plan something quite easily. You plan what energy costs you have in the next few years because you know the energy costs would fluctuate only a certain percent. But nowadays, today, from the war caused in Ukraine, etc., has caused us to have an energy crisis in Europe where we have the topic of huge costs and unpredictable costs as well. This also leads to something that we need to look at as well. So if we have a look at this, for example, the shutdown of central power plants and the fluctuating loads that fluctuating infeed of sources from wind and PV is certainly something we need to do. Grid codes are very important. Fast growing of CO2 taxes in many countries. And also the funding of these projects as well, also very CO2 relevant. The pension funds giving money to these projects also want to see that we are doing something for the planet, so minimizing CO2 footprint. And also these utilized grids, brownfield sites at the moment, we have issues because these grids weren't planned for e-car charging, weren't planned for the structure we have today. So we have to have something to support the systems, future-proof and manufacturing dependent, so people can actually buy from the open market, not only buy from a certain manufacturer. So if you want to break new ground, you have to leave the old paths behind. So the old ways of generation using coal and gas exclusively has to move into what we're using today. So if we look at this topic as well from the distributed power generation capacity, if you look at the year 2000, it was 20%. 2015 is around about 30%. And year 2030 is expected to be about 50%. So these renewables, PV and wind, are definitely pushing into the energy generation market, power generation market, which is certainly going to contribute to many different types of investments. Just one example, what I just wanted to show here, the old energy landscape where we had the power station in the middle, supplying its customers from its central base. And what would happen if the power station go down, like in South Africa, where they have shortages? Everyone goes down. No one has energy. And of course, nowadays, using microgrids, if something goes down, you're only affecting that area that is going down. The neighbors have got their own generation. They can go into island node. They can generate their own energy. So the microgrid is actually on the grid edge. We have the adaptive grid, or the the traditional grid on the left-hand side, and on the right-hand side, the prosumer, the consumer, who's also being actively investing in his own generation, etc. And the microgrid comes dead in the center because we're actually integrating these 2 points together, because we've got the energy storage topic coming to it as well, e-mobility charging as well, and also the distributed energy systems, which we're combining into a solution for the consumers and for the users of these systems. So if you look at, there's some charts I picked up on Google from the sources of the predictions of microgrids. One of them predicts, $40 billion of microgrids by the year 2028. The other one is $66 billion by 2029. So whether these figures are right or wrong or optimistic, it doesn't matter, but there's certainly a growth in this area we can't ignore. The consumers, the users of these microgrids, certainly by implementing it, have proven that this is something that they can do and they want to do as well. So where do we sit? We sit in the middle. We are the conductor of the orchestra. We are the brain behind the system. We control the primary resources of the generation in the microgrid. We control the local generation in the grid to make sure there's a balance between the load and the generation as well. So we have the economic and the energy efficiency topic that here is very important. We have the resiliency and reliability topic, which is important, and sustainability, which we shouldn't forget as well, which is nowadays not in every country and not in every business, but at a certain point we need to look at, and certain customers place a high value on this topic. So the microgrid sits in the middle, connected as an island or not an island, depending on what the application should be. So from the microgrids, we have different systems where they're used in different countries, for hospitals, industrial sites, critical infrastructures, etc., where we have this. And we can have a microgrid implementing this and creating use and positive things for the customers. So let's have a look at the system that I'm busy selling at the moment, I'm promoting, is this microgrid controller. From a hardware basis, it's a very solid hardware platform with automation functions, cybersecurity, the communication protocols, and on top of that, the complete software functions for demand charge reduction, e-car, connectivity, e-cars, etc., generation and forecasting, etc. All these information, software features that we can put onto this platform will make it a highly, highly flexible type of platform. So we have the center of the microgrid in the middle and the SCADA system at the bottom. On the left-hand side is the traditional microgrid, typical information. Most microgrids in the old days used to be PV and diesel. Nowadays, PV, diesel, and battery. This is very, very common for the smaller microgrids. And these features would be fulfilled there. And then we get the advanced features as we're going on to the new technologies, new things, new challenges, etc. One highlight I want to just mention here is market access. So for example, if you have an excess of energy, what are you going to do with it? You're going to curtail it, or you're going to try and make money from it? In our system as well, we have the possibility of selling it into the market and making sure that a customer can make a business case out of this. So from the hardware point of view, I just wanted to show we have two different types of CPUs, a smaller one and a larger one, and the larger one has the possibility to also work in redundant mode. So when we're talking the word resiliency as well is very important, because we can also supply a redundant microcontroller, which is also increases the resiliency for the customer in the critical infrastructures, etc. And these are some of the things you can build into a cubicle and a touch panel on the door for it to implement it as an example, which we have here. So from the simplified HMI, we have two types of HMI. One, the integrated one in this, is we can see the various applications for the operator, well, not the day-to-day operator, the casual operator who comes once a week to have a look at the plant. You can look at it and operate from this system over here like this. You can see a very, very simplified system connecting to, showing the single line diagrams, connecting to the wind park, etc., showing the information required for the system. We also have the SCADA system. From the SCADA system, you can also see the loads. You can see the various assets, the status of what the assets are, what they're producing, thermal loads, the state of charge of the batteries, etc. This information is also important for you as well. Also, whether it's grid connected or not. So for the microgrid, this HMI would also show all the information. And also, We offer these templates as well in our projects to offer some customers some ideas what they can use for more complex systems. In the previous session, they talked about you need to plan properly. And so what we've done as well, because we know that a lot of customers use Homo Pro. It's a commercial software for simulation of microgrids. So we have an API for our microcontroller that you can plug into the Homo software, and you can simulate the microgrid to be as close as possible to what we would deliver with the microcontroller as possible. The performance should be the same. So this is something that we've done, and it also helps someone to ascertain in the planning whether his PV is too big or too large, and also what type of return on investment he's getting, etc. Because there's also something he's looking for if he's going to invest, when's the return on investment, if he's looking at the business case as well. Obviously, Siemens also has its own software called PSS.de, where we also do simulations as well, but this is obviously more complex software that we have. And we also adhere and comply to various standards and things like this. What I found in the previous, when I talked to customers in microgrids, the industrial customers, the private sector, not really interested in certificates. They want performance. They want to know exactly what they're getting for their money. And utilities tend to ask a lot for these norms and these certificates. So we will fulfill them, and we will try and supply them if we can, if we have these certificates. But like I said, typically doing the job is the main thing here. And not forgetting one important point in our microcontroller is IPsec as well. Cybersecurity is part and parcel of the product family, making sure that we have a secure system for the customers, that there is a secure from any hackers hacking the system and switching it off and causing a disruption. We obviously play a very, very high emphasis on this security system as well. So we go to the applications. Where's the CCAM platform used? It's used from the complete energy cycle, from the industry, the power generation, the substations, and also into the consumption consumers, as in for load shedding, generation control, substations, self-healing, etc. All these applications can be based on the CCAM platform, and the CCAM platform is the hardware, and then you put the application on top of it, making the software very incredibly flexible. So from the, let's say, cousins or part of the portfolio from the same R&D team, we have the microgrid controller, and let's call it a subset, the load management system, PMS system from that as well, and also the PPC as well, power plant controller for PV plants, which we are the same using the same algorithms such as every microcontroller. So these are basically cousin systems that work harmoniously together, which you can use as well. So we have, whenever energy plays a role, we can use it in whichever, in industry or in PV plants or the microgrids, etc. We can use the same applications. We have various templates, projects that we offer as well. So these are some of the offerings that we do have if the customers ask and require for them. This is an example of what theoretically we can do. I say theoretically because a microgrid typically doesn't have 16 generators plus 3 PV plants plus 3 wind plants plus 4 BS, 30 load and charging groups. This is a theoretical, but this is basically what we could do if you wanted to. So our system is very robust and expandable, and also with the various protocols that we have to fulfill many of these applications, etc., that are required. And obviously, with the microgrid, the protocol which one has to have is Modbus TCP, because it's the most common protocol connecting to the inverters. But obviously, we also have the ISC norms, the 104, the 61850, etc. These protocols can also be used connecting to the substation, etc., or connected to protection relays. Okay, some of the key points we have, it's an application, the microcontroller's application on the hardware. It's a transparent system. It means you can grow it, it can expand. Extremely fast cycle time. It's outstanding technology, and also fits brown and greenfield sites. We might have a site that's an existing substation automation system, and you want to put in the PV and the diesel genset as well for the customer and create his own microgrid, you can expand the system using the same SCADA system and also maybe using the same hardware. But obviously, we have to look at to see what generation when this other system was delivered. But this is something that's also possible. Let's go through some references. I think this one is, I think everyone knows this one. This is very, very commonly known in Thailand, the EGAT project, the floating PV project, where we got the dam and the PV. And in this technology where we have here the microgrid control system connecting to the PV plant and to the hydroelectric plant, giving the information for the operators to operate the system accordingly in the correct possible way. What's also connected here is a cloud-based system where we give information to the cloud, where the headquarters can look at in a dashboard to see what they're looking at, what they're operating, and maybe some key features that they're looking at. So this is also a very interesting topic. We have the 3 portfolios in here as well from this project as well. Just to show a bit schematic what we have here, we have the in-feeds, the dispatcher control center, the SCADA system. We have the control system connected to the cloud-based system, connected to the hydro plant, connected to the storage, which is planned for the future, connect to the PV control system, the CCAM 8000. You can see it's harmoniously connected together, and all these various applications that we fulfilled here to get a good project out of this. The project, what I'll mention here as well, it's another interesting project, is Lemene Commercial Campus in Finland. This is, I would say, has got all the features that one would look at. A customer approached us, said he wants to have this industrial park where we'd like to have it islandable, but he'd like to have it green as well, being in Finland. And what we produced with this, we worked with this, for example, he had 6 CHPs, 4 megawatt, 2 solar parks with 4 megawatts, batteries, fuel cells, etc. And this is the system that he created. But what's the most interesting part of it from this here is he has ancillary services. So therefore, he's selling the features of the generation, the excess generation into the grid, and also making money from it. So his return on investment, I wouldn't say is in years. I understood that it could have been in months. So he has got his money back very, very quickly from the system. And being totally automated before in the old system, in the previous system, which had the CHPs, you used to have people working 24/7 on site. Now only is on normal work days, 8 hours. One staff is there to look after the system if need be. The rest of the staff is on call if need be, because the system is totally automated. So this is a very interesting part of it as well. So if you look at the HMI, as I mentioned, the various topics, they have thermal loads, power exchange, gas engines, photovoltaics, fuel cell storage. And also with this topic of here is cost and carbon footprint, which we thought was very important, and to see at any moment in time what the renewable share had of the site is at the moment. So this is when we took the snapshot, it was 20% or 28%, I can't read the text, but it was at that time. So this information is embedded in the system. So if you need this information for any other topics or statistics, we can extract from the system and show it in another way. What I wanted to show from the ancillary service, what we're doing with this one here, we've got the whole palette of all the assets, generation assets we have, and we're participating with the FinGrid for these various aspects. This is where they're making their money. This is where they're getting the return to invest. This is a very, very interesting project because, like I said, the return to invest is far quicker than what we would imagine. They obviously wouldn't tell us exactly what the return on investment is, but we reckon it was in months, not in years. Okay, we also talked about microgrids, etc. In the previous panel, we talked about simple systems like this. For example, we have an Upper Blinkwater community, 62 households, and they also wanted a microgrid. And we worked with DLR, which is an institute in Germany, which also funded part of the project. And we built up a microgrid to replace the diesel gensets that they're using exclusively, put a PV plant into it, and also a battery into it, and we monitored to see what they're using. And so what the previous panel also said, as people start using electricity, getting used to it, they start buying more components, buying more fridges, buying more electrical items, that they increase the load. So this is what they're monitoring as well to see what the characteristics of these villages is, and then we can go into a phase 2, perhaps also put wind generation if the wind is blowing at night, and we can actually get the wind to offset the diesel that might be at night, and also the battery that might not be big enough. So that's also something what we did in this project. Then obviously Siemens also puts its investment in its own buildings. We have various campuses around the world, Siemens campuses. One campus is in Princeton. We also made a microgrid there. From the rooftop of the car park, the car park had panels, and we feed it into the grid to reduce our CO2 footprint and also decrease costs as well. We have another microgrid in Midrand in Johannesburg where we have approximately 1 megawatt of PV and the load of about 600 kilowatt, and therefore we have more PV available as peak than we have as a load. And we would feed this into the grid, and we would hope that the city council would give us the money for what we feed into the grid. At the moment, there were still discussions on how that was going to work. So this is also showing that we have microgrids also in Siemens campuses. And one of them over here we're looking at here is the Siemens microgrid campus in Vienna. Here, looking at the Vienna campus, we have two sites of rooftop PV with the Carco string inverters. We have a battery from the company Fluence, which Siemens owns 50%. And we have various charging stations around the site for e-cars. And of course, the profile of an e-car of a staff member versus a customer is different, because a staff member would be typically 8 hours a day and be charging the car during the whole day. And a customer would probably be there for an hour, and therefore his charging profile would be completely different. And this is also what we've catered for, this being a totally flexible system. What you see quite interesting here on the bottom here is this 4G. We actually worked with Nokia to try out the industrial 5G network in this system as well. So we connected the microcontroller with this 5G network with Nokia. So just some interesting side there. And we also connected to the building management system as well. So the whole thing is integrated into the site, also reducing the CO2 footprint. I think reducing 100 tons of CO2 or 100 tons of CO2 reduced per year, energy efficiency, etc. And these are the topics that we dealt with. Looking at the schematic of it again, e-mobility is very important, the renewable generation, also the storage system as well. We collect the weather data, we can forecast to see how the PV would react. Obviously, having bad weather, obviously we'd have to use it in a different manner. The charging and also the various other aspects we have the microcontrol, controlling the charging of these cars. And like I said, we're doing the peak shaving, and the main topic here is CO2 reduction. So from the microgrids, the yellow dots are PV plants, but the other dots are microgrids where we're situated in various countries. We've got some projects not shown here. For example, we've got some mines in Australia as well. We have projects in India, we have projects in the Middle East. This project in Africa is in Mali. Project in North America, and we have one project in South America. We're planning to have some more projects there as well. And of course, a lot of the projects are based also in Germany as well, and in Europe. Basically, when our product from our portfolio, we're supporting 43 clients worldwide, and we're managing more than 2 gigawatts worldwide with our system. So it makes it quite a substantial system. So basically, the last point I want to bring is secured and sustainable investment from our portfolio. The quality that we can bring, we always deliver, and also energy efficiency of the customer, so he's using the equipment that makes his life easier for the energy efficiency topic. And the last point that I want to highlight here is ideas alone have very little value, and innovation's importance lies in its practical implementation. This was said by one of our founders, Werner von Siemens, in 1865, and it's so true and so relevant today. And that's the last words I have for this presentation. I'd like to thank you for listening to my presentation. Thank you.